One of the unrevealed mystery of the cosmology is the dark energy. Unlike the dark matter, there's not much modality in the dark energy because um, the properties of the dark energy is quite different with the radiation or matter. The evidence of the dark energy comes from the observations from the supernova. As a standard candle, we can measure the Hubble parameters H0s and the CMB and the BAO by considering the integrated Sax-Lopez effect. The most well-known models of the dark energy is the cosmological constant, just assuming the additional term in the Einstein field equation. Then in the Friedmann equation, especially the first one, there is the contributions from the cosmological constant capital lambda. But the problem is uh, the required cosmological constant scale for the cosmology is extremely small compared to the vacuum energy which comes from the quantum fluctuations. The energy density of the cosmological constant rho lambda defines as a capital lambda over the 8 pi c. This can be also uh, estimated from the critical energy density and the dark energy ratio. Then the scale is roughly 10 to the minus 48 GeV to the volt power. But from the quantum field theory, the vacuum energy density is given by the cutoff scale, which corresponds to the uh, Planck scale, and this is quite large, 10 to the 18 GeV volt power. So compared to the cosmological constant, there's a big discrepancy between the vacuum energy and the low lambda. This is called the cosmological problem. So such a constant dark energy is not sufficient to explain the cosmology, and especially recently the DASI observations report that the equation of the state of the dark energy might not be the constant. So this demands the dynamical dark energy in which that the energy density and the equation of the states are not constant. And that such a dynamical dark energy model can be realized by using the scalar field like as in Platon. And such a dynamical dark energy can be also tested by the observation. So today I want to talk about the several dynamical dark energy as overview from the Quintessence and the other possible model. The well-known dynamical dark energy model is a Quintessence. These terms originated from the fifth element in the Greek uh, language. The scalar field pi shifted the subdominance in the early universe, but recently it became the dominance in the energy contributions, and it should satisfy the slower condition to realize the rapidly accelerating expansion. And the important properties of the quintessence is the tracking behavior, also called attractive. So, so the tracking behaviors mean that the even though there is the wide ranges of the initial condition, but it eventually follows the common evolutionary path. Uh, we will show that this tracking behavior with some specific parameters, dimensionless parameters lambda, with for the given potential of the scalar v pi, we can obtain the lambdas with the v prime, such M Planck lambda v the multiplies the for the dimensionless quantity, and for the second derivatives of the v, we can define the lambdas, capitals gammas as following, and the tracking conditions given by the capital lambda should be the larger than the one. Such a form of the lambda can be interpreted as the some slope of the exponential functions form of the scalar potential. If we assume the locally constant lambda and solve this differential equation, then the scalar potential form is given by the exponential minus lambda pi through the Planck. So the magnitudes of the lambdas correspond to the slope of the scalar potential, and the small lambda can realize slow roll condition. So by using the sum algebraic calculation, the time derivatives of the lambdas and using the chain rule, we can obtain the relation between the lambdas and the capital gamma. That denotes this equation of the star, and we can show that the small lambda and the capital lambda is greater than one condition, the tracking condition, such as two situation can realize the tracking behavior. So let's assume that the slope of the scalar potential is negative. The v prime is less than the 0. Then by definitions of the lambda, the sign of the lambda is the positive, and by the relations, this equation star, then the lambda dot is the positive, and this gamma minus 1 is negative by this condition. So the pi dot becomes a positive. This means that the right. So lambda pi dot is the positive because the scalar potential is negative. So it goes to the potential minimum. And okay, so the pi dot is the positive and this is negative, so the lambda dot becomes the negative by the equations star. So for the positive lambda, the lambda dot becomes the negative, so the slope lambda go to some specific limit, especially the lambda go to 0. And for the opposite situation, for the v prime is the positive, then reversely the lambda is the negative by definitions, and the pi dot is negative. Scalar goes to the potential minimum, and by the equation star, the lambda dot becomes a positive. So the negative lambda make the lambda dot becomes a positive under the tracking conditions around the small lambda. So the slope of the potential go to the zeros as the time go to the infinity, and this realizes tracking behavior. But this is the quite general pictures, not the quintessence one. We don't propose some specific potential form yet, and also there should be the additional condition. The scalar build pi shift the dominance in the right time from the equation of the state omega pi defines as projects divided by the energy density, and from the some calculation we can obtain the energy density ratios of the scalar field, and I'll skip the detailed calculation. And if the slope lambda decreases, then the energy density becomes the dominance in the right time. And also the slow roll condition should satisfy the equation of state around the -1 or the less than the -1/3. Also we can obtain the relation between the energy density and the equation of the state. The capital gamma is greater than 1 as the tracking conditions, and the omega pi becomes the 1 in the right time, the dominating the scalar field. So the equation of the state omega pi is also the near the -1. So here is some concrete examples of the quintessence scalar potential. The simplest possible one is the exponential potential, similar to the power law implementation. But the problems of this exponential One is the scalar field cannot be dominant, and the scaling attractive behaviors occur. So the commonly the quintessence model is the inverse pulse potential, so-called lateral Peebles model, like as such a boom. Such a inverse potential boom can be generated by the dynamical CG breakings naturally, and we can check this potential satisfy the tracking condition by using the second derivatives of the scalar potentials, and we can obtain the tracker solution. So the for the scalar field also it satisfies the following equation of the motion is in the expanding universe, and if we insert the Hubble parameters as the time forms and the first derivative scalar potential, and the tracking solution has the following form. The constant C has some complicated functions of the Q and the nu, and we can check the tracker solutions. Even though there are the wide ranges of initial condition, it eventually go to the tracking solutions in the right time. This can be shown by the also the this inverse power potential form rather than the dimensionless parameter for the tracking condition. We can obtain the balls from the first minus sign with the first derivatives of the potential, and if the initial conditions, initial scalar field is larger than tracking solutions, or the vice versa, the uh, let's let's consider this condition. So the initial field value is smaller than the tracking field value. Then we can obtain the both for the initial field values and the both for the tracking field value. Then from under this assumptions, the both for the initial field value is lower than the both for the tracking field value. So the eventually follow the tracker solutions, and for the reverse situations, the vice versa. So this is for the quintessence models, and I will turn to the some other several possible models, but this is not uh, well known and popular. The other possible one is the quantum dark energy, which is the equation of the states of the dark energy is less than the -1. This requires a long science of the kinetic term of the scalar field, because the omega pi is defined like the project divided by the energy density. Under this long science of the kinetic energy, now the energy density has a minus sign, but the project has a plus sign, and in the slower conditions, the potential energy is the dominant, so the omega pi is now the less than the -1. And also equation of the motions has a minus sign still in the v prime, so the scalar fields to go to the potential maximum, the field slides up over this potential. But the problems of such a long sign, the negative signs of the kinetic term, is the ghost field problems in the quantum field theory. This breaks the unitarity and unbounded potentials. So the to make the ghost free model, the multiple dark energy field requires. The next possible model is the K essence, which is kinetically driven quintessence. Already we discussed the K essence, K impulsion, kinetically driven impulsions. In such a K essence or K impulsion, the slower conditions are not really derived the scalar potential form, rather than the potentials. The kinetic term has a non-canonical complicated form. Usually the kinetic term is given by the functions of the pi and the lambda pi, such as some booms, and we can obtain energy density and the projects from such a function p. For example, the Lagrangian has such a combination where the axis is defined by 1/2 the partial pi scale. The other dark energy model is coupled to the other sectors, especially the coupled dark energy still with the neutrino. It is called the mass-bearing neutrino. Because the such a motivations of the mass-bearing neutrino, so-called MaVaNs scenarios, is a similar scale and the size of the energy density of the cosmological constants and the neutrinos mass. The equation of the motions becomes a couple. In the right hand side, there's energy transfer between the dark energy neutrino surface, and this gives effectively changes the equation of the state from the neutrinos non-zero mass. So the coupled equation from the continued equations are given so like that is term represents the energy density between dark energy neutrinos, and also the neutrino mass that varies along the slow rolling scalar field. The final model I want to discuss is Chaplin's, because maybe this is the names of some scientists. This is a fluid-like. Unlike the equation of the states, now the projects are proportional to the inverse of the energy density, and this can be also realized by the complicated models with the scalar field. And by the results of the dark energy, we can imagine the end of the time in the universe. There are three possible ones. The big crunch if the dark energy becomes the subdominant state in the futures, then also the gravitational attractions become stronger, than the scale factors go to zero at a specific time t star. But there are also the other scenarios, the big leap and the big freeze. If the dark energy becomes a more dominant in the future, and eventually the older matters and also some composite particles separated, then the scale factors go to the infinities, go to the big leap, or the if the dark energy just maintains, and this is I go to the some specific values right star. Also, these three scenarios of the future sort of the universe can be uh, analyzes quantitatively, but I don't want to use the details in here. So today we talk about and discuss about the dynamical dark energy from the quintessence and the several model, and such a dynamical dark energy model can be tested by the recent observations. And unlike the dark matter that has the several model, the dark energy is not investigated very well still.